Welcome. Here, we break down complex electrical engineering concepts into simple, practical, and engaging explanations. So stay connected with the world of electrical engineering.
This is the conducting portion of the bushing. This is either a rod or a hollow pipe made of copper or aluminium, depending upon the agreement between the manufacturer and the customer. The diameter of this rod or pipe is an essential parameter of the bushing because this portion of the bushing has to carry the rated normal, short time overloading, as well as short circuit currents of the transformer. This top portion and this bottom portion are designed so that they can be properly fitted on the bushing housing and provide hermetically sealed joints with a gasket. This is the kraft paper wound on the conductor. The length and thickness of the kraft paper dielectric are calculated for proper distribution of voltage in a capacitor graded bushing. On that kraft paper dielectric, we wound aluminum foil. This foil acts as the metallic plate of the capacitor formed by the central conductor and the dielectric medium, that is, kraft paper insulation, and this aluminum foil. Again, on that aluminum foil, we have to wrap kraft paper again, but this time we have used a shorter breadth of kraft paper. This is also pre-calculated for proper distribution of the voltage. We cover this second layer of kraft paper with aluminum foil as shown. This makes the second concentric cylindrical hollow capacitor from the center of the conductor. Now again, we wrap kraft paper on it, and here the breadth of the kraft paper is again shorter than the previous one. This shorter breadth is also pre-calculated depending upon the proper distribution of voltage among the capacitor grading. Naturally, this will also be covered with aluminum foil again. Then we wrap a further shorter breadth of kraft paper on that aluminum foil. This is also pre-calculated. Then it is covered with aluminum foil. Although we have shown only 4 such concentric hollow cylindrical capacitors in our demonstration, practically the number is much higher, but for the sake of understanding, we have only shown 4 such concentric hollow cylindrical capacitors. This is the 10 delta terminal projected from the outermost aluminum foil of the condenser system of the bushing. Here some insulation is provided. Why have we provided this insulation? Actually, this insulation isolates the 10 delta terminal, that is the outer aluminum foil, from the metallic flange. Here, we remember that we connect an aluminum foil below the outside capacitor, not the outermost capacitor foil, although we have shown the outermost layer in our demonstration as grounded. In practical cases, the metallic flange is externally connected with a short piece of conductor to the 10 delta terminal, so that this aluminum foil always remains at earth potential or zero potential. This is the insulator housing. It is either made of porcelain or composite insulating material. From the flange to this portion remains in the air when fitted on the transformer. The length is decided depending upon the required minimum clearance of the live line from the earth, and these sheds serve as rain sheds as well as provide the required creepage distance. The length of this lower portion depends upon the minimum required clearance in the oil from the lave bus to the earthed metallic structure or metallic tank. Here, since it will be inside the transformer and immersed in oil, creepage distance need not be maintained. So there will be no atmospheric shed or rain shed. It is plain, you see. Now we provide the expansion chamber on the top of the housing. This expansion chamber provides adequate space for the oil to expand and contract. This is the oil gauge from where we can visualize the level of oil inside the bushing. Actually, the bushing is hermetically sealed from that portion to that portion, and the entire housing is filled with oil up to this level. If we see only the oil inside the bushing, we observe that the entire condenser arrangement is inside the oil, and the oil is up to this level. These two are the hangers fitted on the flange to handle the bushing.
Thanks for watching. We hope this video helped you understand electrical engineering concepts better. If you enjoyed the content, don't forget to like, share, and leave your thoughts in the comments. Stay with us and stay updated with more videos on transmission lines, substations, and power systems. Until next time, stay curious, keep learning, and keep the power flowing.